Okay, I hope this video is recording, and I also hope that the screen you're able to see the screen. So in this video, I'm just going through very quickly on the basics of open roads that we discussed in the lab. Um, so there are four tasks that you need to do as a part of this lab. The first one is creating the horizontal alignment, uh, creation of the vertical alignment, and very simple way to create the super elevation. And at the end, we will see how to create the 3D cut fill report out of the um, session in OpenRoads. Now, so there will be four different files that will be provided to you. The first one is called Corridor Route 97 Geometry. This is the TIN surface. The fourth one is the terrain 3D. What I would want you to do is put all of these files in one folder, and we will work with those files in the open roads. Um, a part of this work here, at the end, what we need to do is we need to put the cut and fill for the whole whole section, and we will also find the cut and fill for each of the sections, and then we will also fill them here. And like I said, this session here is just going to be very introductory. So this will help you exam or in your task, the length of the horizontal alignment and then the length of the vertical alignment might be different, which will be according to the engineering design. But here I'm just going through over the basics. Now, the first task from our requirement is to create the horizontal alignment. So in this one, we already have the file with the PI. So PI is the point of intersection. So if you open this geometry file up, it's taking some time. While this is opening, I'm just opening up the Excel sheet as well. So if you see the instructions here, uh, we need to obtain the cut and fill for the earthwork, and also that will consist of all the terrain, geometry, and the corridor. So I've provided. So you'll be provided with three different files. The first one is the terrain file, geometry file, and the corridor file. So we all need to put them in one by using the reference, by referencing them in one file. At different cross sections of this, we obtain the content field and then verify with the overall artwork. It's still loading. Um, home. Okay, when this file is loaded here, what we see is there are the PIs already given, loaded in this geometry file. Now, the first task here is to create the horizontal alignment using the complex by PI tool. So how or what we need to do is in the home, make sure that this is your OpenRoads modeling. Go to the geometry tab, and then in this horizontal here, there's this complex geometry. Go to this complex by PI, and your task would be to get the center of each of these PIs and then join like this. And then this radius here, it's basically the radius of the horizontal curve, which if it's given to you, you'll have to change it accordingly. But in this case, I'm just putting it the default that's given by the software, which is 700. So there are 4 PIs. So here, so and then when you join all of these, right click to come out of the command. So basically now what we have is we have the horizontal alignment for that joins the 4 different PIs. Okay. After this, if you go to this here, include at least 2 curves with the defined radii r equals to 500 and 400. So here there are 2 curves. The first one is here, and then the second one is this one. So if you go to home, select this. Okay. And then when you select this, you will see that the radii of this curve is 700, and then this one is 700. If the radii of this horizontal curve is given to you something other than 700, then you just need to edit that. Okay. And after that, that's basically define the start station of 10. So for that, go to this geometry here, modify, start the station, select this. The start position is here, right? And then the parameter station is given, I believe, how much? 10. 10 plus 0. So what you can do is you can type in 10 plus 0, 0, 0, enter the element. And then when everything's done, then you can do the left click, and then to come out of the command, you do the right click. Okay, so your start station is 10 plus 0. That's how we do the uh, we denote the start station. Okay, now the next thing here, to create the vertical alignment, we need to have the profile model active. So for that, what we need to do is come over to um, this road here, this alignment, hover your mouse, and then in the second portion here, there's this open profile model. Click on that, and then you can open up any of the views. Let's say 5. Select open view. Be sure to click here. So our profile view is here, but we are not seeing any road, like the actual land. In order to do that, what we need to do is go to home, attach to. Let's attach all of the references here. Let's attach everything. Then here, go to this option here, and then you can attach this corridor. Open. Okay, attach this geometry. I think its geometry is already there, but we can do that as well. I don't see it there. This terrain open. So we have attached the corridor, terrain, and then the geometry here. Okay, so let me pull this up. Okay, anyways, so we have them. Let me see here. Do we have them? I see that the file is not found. So Tito. Okay, I see it there now. It's here. Let me do the terrain as well one more time. Coincident world. Okay. Okay, I see it here now. So we created our own road based on this is the terrain here. This is the corridor. The first thing that we do after this one is go to this, select the terrain, then activate this, the second option. Okay. Okay. When we do that, now go to this four. I think that was four. Okay, five, which is the vertical section here. Then when you activate the terrain, you will see the roads here. Now, uh, in order to create the vertical section, we have to work here in this profile view. So what do we need to do the second step here for the vertical alignment? Go here, go to the geometry. You see this vertical here? Okay. Now go to this option here, profile complex by PI. Whenever you see this enter first PI, so this is basically I will be giving you, or you'll be provided um, with the with the length, the slope, and the curve. But at this point, I'm just you see here how the slope is changing. Whenever your slope is fixed, you can click this here. But I'm gonna do it here. So this will be provided to you from which station to which station. So this is the vertical alignment. So I'm gonna put it here, something like this. Okay. So this will be provided. And normally, the vertical alignment should be about this terrain location. Okay, as is for an example, I started from here. Okay, when you have this, so this point here, you can set this as well, just to they are kind of setting it. So here, when you have the vertical profiling done for whole of this section, we're basically done. Okay, so in this second here, create the vertical alignment with the two vertical curves, length equals to, and yeah, this length and this, then the grades will be given to you, or you will know that from the calculation. After this, set the vertical alignment as the active profile. So we need to go here, select this, hover this, go to the second one, active profile. So we need to do that in order to set this profile to your vertical alignment. Okay, after this, we're basically done with the second portion. Now the super elevation. For the super elevation, what we need to do is uh, go to this corridor section here. In this super elevation, there is a create. So go to this create super elevations. Okay. Name, that's okay. I am. This is everything's okay. Everything's okay. So uh, name is okay. Look at the corridor alignment. So you can look at this corridor here, and then this parameter rules file. if you want to, if you are asked to change this rules file, so you can come here and then change this here. I'll be using this e-selection. You can use if it's given something else, you can use that. If not, you can do that. Then this everything looks okay. Okay, then come here. Here, parameter length. If you have a different tangent length, you can use it here. Select this. Left click. Name. You can change that if you want. Look at the corridor alignment. Oh, I think the super elevation is already created here. Okay. Here. Okay, yeah, that's already created. Okay, so when we're done with this, just do a right click to come out of the command. After that, I think the calculation can be done. Go to this and calculate the super elevation. The rules file name, it's going to be same here. Look at the first super elevation section. Click on this one. Look at the next super elevation. You can reset to complete. Right click. This is okay. Left click. Left click. Left click. Left click. Left click. Left click. Okay. So at the end, the super elevation will be created and calculated as well. We can review the super elevation section as well. Okay, you can do this to kind of look the super elevation view. Maybe in this section here, come to next view and then select open view to get the super elevation section. If I ask you to change the super elevation views, you can do it from here. But if not, then that's how we do. Okay, that's for the super elevation part. Let's create the super elevation using the 4-lane divided highway template. So that, I think I missed talking about that. So for that, you need to go here, create super elevation sections. You go here, start location. You can do that anywhere at the start. And location here. You can do this, left click, and then whenever there is a parameter lane creation template, you just do a left click, okay, and then the lane will be created here. So this lane will be created here based on the template. The template can be changed as well, which will we can see the options there. Now for this one, you can actually see the cross section view as well here, but we're not doing that here this time. Okay, so that one was for the third as well, super elevation. Now the fourth one, the production and reporting. There are two things to remember here. The first one is go to the home, and then here's the model analysis and reporting. The first thing to do here is go to civil analysis and then create the cut field volumes. Okay, and then volumes cut is okay. Left click, left click, left click, left click, left click. Data point to accept the selection. So go here and over there in the corridor, just click left click. You will see it's designing or it's calculating the cut and fill. So it calculated the cut and fill. Now our task is to see. So for that, again, go to home, civil analysis, quantity report by named boundaries. Uh, so named boundary group, nothing known to this. Left click, and you will probably see the report that's popping up like this. And you find this cut and fill here. The fill volume for the total fill volume is 59836. So you come here, 59, what was that? 59836 in the fill, 59836, and then in the cut section here, 19736. It'll be precise to use the point as well. So that's gonna be 0.009 here, 231. Okay, so when we have this, now the next task is to find the cut and fill at different sections. So at this point I say 200. I'm not sure if it's gonna work. Let's see. Um, okay, so for that, for different sections, the first thing we need to do is go to this drawing production, go to the named boundary, place named boundary. Okay, and then come here, come to the first option here, which is the civil plan, and then in this seed here, go to this A1 plan profile. You can keep everything here. Change this to 200. 200. That's what we need, right? Now in this start location, select that road here, okay, and then in the start location, this will not be a tick mark right here, and come all the way this side here, click. Okay, so now when we do this, enter. Let's change the name as well. Okay, after this, okay, so this is all good. Okay, after this, now we have that place, the boundary. Now go to the home here, civil analysis, go to quantity report by named boundaries, and here, okay, I still do not see that named boundary created. So let's go back and see if there was an issue creating the named boundary. So we have this here, start location. I need to create this. Okay, so I just did a 2 times double click here so that I can see those sections and I was missing. So after that, let's see the final cut and fill. So here, yeah, now you see this unnamed plan because we did not name it. So it was not here before, but um, we did that, and then here unnamed plan, left click, left click. Now it's creating the cut and fill for different sections. Okay, so you'll get a different report now. If you go here, 10,201. So you have different cut and fill. So this is 3065 .948. That's the fill. 3 at 200, right? 3065,948. 3065,948. 3065,948. So cut 2428 662 2428 662 here. 2428 662 is the cut. 2428 662. So this is for 400. These numbers might be different, but that's how you get. So this is for 801, which is 1331.489.883. Looks like the volumes fill is here. Let me see here the volume. Okay, volume fill and volume count. That's okay. So we're just trying to find or get the data for each of these sections. OpenRoads uses the prismoidal method for calculating the uh, cut and fill here. 1244.561. This side is 4138.010. Not this one. Oh, 4138.01, 4138.01. So now for 14, section number 14, this is going to be 66.532, 4361.611. Here, 1500.470, 256.869. This fill is going to be 206.965, 3729.848. This one is cut is 919. Cut is 919.141. The fill is 254.946. Now for the last one, I don't think we have. Okay. Now your task here is to see. So this one was the total that we had, but if we just calculate it for each of the sections, there was a huge difference, right? So this should have matched here, but the reason it's not matching or there is a difference here is because there is some volume here at 2000 plus, which is basically over this area. So we don't have the area, we don't have the volume for that. So for this exercise here, what I would want you to do is um, over here, this minus this, okay, and then this sum it up to down here, this, okay, cool. Here in you need to subtract, let me do it here. The only thing is we need that gap, so I will subtract this minus this here, and then I will put this number there, okay, and then increase the summation down here, okay, that's okay. So the only thing is now this and this has to match, okay, and this will match because we are just subtracting, okay. This minus this is what you do, and we have the same number here. I just did the opposite thing, minus t20. This minus this is what we need. Okay, that's okay. This the only thing is the verification here should be the equal number. So for that reason, I've been trying to do this. A6 minus A20. This one here. Okay. Anyways, the whole idea here is to put the this is an error minus D20 because I'm trying to do the fill here. Then I bring it here. Now this has to be Control C and then paste with the number. This one here with this sum here. Yeah, there you go. And we get rid of this. The whole idea is for this 2,000 plus section here in this diagram here, this much small portion, the cut and fill is used. That's what we can see at least. The verification should be 0. Okay, yeah, that's all for this here. What we did is we created the vertical alignment, horizontal alignment. We did look into how to create the super elevation, how we calculated the super elevation based on the template, and then at the end we just looked into the reports from the other field, cotton field, and then we tried to verify the numbers for the total cotton field with that um, for the sections. Okay, thank you so much, and thank you for listening.